Hello everyone. Now we can discuss about the gravitational potential energy. What is gravitational potential energy means work done to bring the object from infinity to gravitational field to any point in the gravitational field is called gravitational potential energy. Once again, work done to bring the one object from infinity to work done to bring the one object from infinity to any point in the gravitational field is called gravitational potential energy. Now, for that purpose, the definition will be this one. Now, first I am taking one object. Mass of the object is m1. Mass of the object is m1. Now, another object. This one I am taking from here to here. Distance it is nothing but a point P. From here to the point P distance is the r. Here to point P distance is the r. Isn't it? Now the object is we are bringing from the infinitive distance. Now m2 object I am bringing from the infinitive distance, and it is, this is mass of the object is m2. Mass of the object is m2, and from first object to center of the first object to center of the second object distance is nothing but a x. Center of the second object distance is the x. Now I am taking from point A to point B. This is nothing but a small distance dx. Small distance is the dx, isn't it? Now I am writing what is the work done to bring the second object from A to B. What is the work done to bring the second object from A to B? For that purpose, I am writing dw is equal to force into displacement. Here displacement is nothing but a dx. What is the force? Gravitational force. Gravitational force is the capital G and mass of the first object, mass of the second object divided by, from here to here distance is nothing but a x, and it is moved, displacement is the dx. See here, this is the work done to bring, work done from work done to displace, to move otherwise, to move from A to B. Work done to move from A to B, that is dw is equal to f into dx. dw is equal to g m divided by x square into dx. Now from this equation I have to calculate what is the work done to bring the object from infinity to point P. From infinity to point P means, how I can calculate means by using of the calculus method. By using of the integration method I can calculate this one. Mean integral of dw. Integral of dw is nothing but a w, that is equal to g m, capital M small m is the constant. Capital M small m, it is the constant. Integral infinity to point P, that is point P is nothing but a distance from here to it is the r. 1 by x square dx. 1 by x square dx. Okay, w is equal to I am writing capital G, capital M, small m, that is infinity to r, x to the power of minus 2 dx. Now integration formula. What is integration formula? I will write here. Integral of x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. Integration x to the power of n dx is equal to x to the power of n plus 1 divided by n plus 1. So w is equal to, I am writing capital G, capital M, small m. This one it is, I am doing integration x. Here my n is nothing but a minus 2. So minus 2 plus 1 divided by minus 2 plus 1 infinity to r. W is equal to capital G, capital M, small m divided by, how we can write minus 2 plus 1, minus 1, and this one x to the power of minus 1 integral. After integration, the limits we have to write right side of the closed bracket. Okay, W is equal to minus g m m. X to the power of minus x I am writing as a 1 by x infinite to r. W is equal to minus z capital M small m 1 by r upper limit minus lower limit. So 1 by infinity is nothing but a 0. W is equal to minus z capital M small m divided by r. So potential energy U is equal to work done stored in the form of potential energy, that I am writing as a U is equal to W is equal to minus z mm by r. U is equal W is equal minus z mm by r. Okay. Listen once again. What is the potential energy means? Gravitational potential energy means amount of work done by the gravitational force in bringing a body from infinity to any point in the gravitational field. See, amount, this object is M2 object is at infinity position. So amount of work done to bring the object into the gravitational field at any point from infinity to particular point, that is work done to bring the one object, work done to bring the object from infinity to any point in the gravitational field, that we are calling it is nothing but a gravitational potential energy. So first I am taking infinity to while I am bringing, for example at a t instant the object is at point A. After t some time interval it displaced from A to B, the displacement is dx. From here to here gravitational force F is equal to g mm by x square. So what is the work done to move from A to B means dw is equal to F into dx. F is nothing but a g mm by x square into dx. Okay. This one, by using of this one we can calculate what is the work done to bring the object from infinity to point B. Point B distance is r distance from here to here. So that's why infinity to r. Just I can calculate by using of the calculus from infinity to r. If I do integration, I got finally work done is equal to minus gmm by r. So potential energy U is equal to W is equal to minus gmm by r. Okay. Continuation only. I want to tell here what is the gravitation. What is the gravitational? What is the potential? Gravitational potential. What is the gravitational potential means? V is equal to gravitational potential. Gravitational potential. Not it is energy, it is potential. It is a potential, not energy. Potential energy is this one. Gravitational potential V is equal to W divided by M. Work done. It is nothing but a work done per unit mass. Work done per unit mass. So it is gravitational potential V is equal to W by M. So V is equal to W is nothing but a G capital M small m divided by R whole divided by small m. Small m get cancelled means V is equal to, you can write minus G m by R. So gravitational potential equation minus Gm by R. If it is a scalar magnitude, if you taken, this is nothing but a plus. Gravitational potential energy equation and gravitational potential equation. So this is gravitational potential. Now we can discuss gravitational field strength. What is the gravitational field strength or intensity of the gravitational field? Gravitational field means it is nothing but a gravitational force experienced by per unit mass. Gravitational force experienced by unit mass is called intensity of the gravitational field. Gravitational force experienced by the unit mass. So for this one, just I am writing gravitational force equation capital G, capital M, small m divided by R square. This is the gravitational force equation and divided by small m. It is the unit mass. Unit mass get cancelled means Eg is equal to, you can write capital G, capital M divided by R square. capital G, capital M divided by R square. See here, gravitational field strength Gm by R square. Actually, Gm by R square, we already derived the equation. Gravity on the surface of the earth. Gravity on the surface of the earth. Both are same. Gravitational field strength, gravity on the surface of the earth, both are same. It is the both are same. We can write this equation, it is nothing but a gravitational field strength, it is a vector quantity. It is a vector quantity and units are Newton per kg. Units is nothing but a Newton per kg. Units Newton per kg. Units are Newton per kg. If you want to write the dimensional formula, we can write Newton is nothing but a kg meter per second square whole divided by kg. Kg get cancelled, remaining meter per second square. So length, mass is nothing but a 0, length meter power 1, time it is the minus 2. It is the dimensional formula for the gravitational field strength and it is a vector quantity. And next one, I want to calculate what is the null points. What is the null points? Null points. Null point. Null point means, see here, this is one object M1 and this is one more object M2. So because of these two, because of the gravitational field, you can observe, for example, at this position you can observe equal and opposite gravitational field strength. So that's why resultant is the 0. For example, gravitational field strength from here to here, total distance is the R. Total distance is the R. From here to here distance is point to O distance is nothing but x. What about the remaining distance is R minus x. Remaining distance is the R minus x. See here, two objects M1 and M2. Null point, just I am assuming as a point O. At point O distance from the first object is the x. From the second object distance is R minus x. Gravitational field strength acting on the point O due to the M1 is nothing but along this direction, that is E1. Gravitational field strength acting on this one due to this one, it is nothing but E2. So both are equal and opposite direction. Both are equal and opposite direction. So you can write E1 minus E2 is equal to 0, null point. So that's why E1 is equal to E2. We know E1 equation. What is the E equation? Just now only we derived Gm by R square. G, here mass is M1. First one belongs to this one. So mass is M1. Distance from here to here distance is the x. This is x square. And G, M2. Mass is here M2. Distance R minus x whole square. Distance is R minus x whole square. Both sides Gg get cancelled. R minus x whole square I am taking this side. R minus x divided by x. Here M2 by M1 I am taking to denominator. M2 by M1. Now R minus x divided by x whole square is equal to M2 by M1. Just I have written for the whole square. R by x minus x by x. R by x minus x by x. That is equal. Root I am taking that side. Root M2 by M1. X by x is equal to 1. X by x is equal to 1. If I take that 1, it is that side. What you can get? R by x is equal to root M2 by M1 plus 1. We need to find out x. X you should take that side and this one is R divided by under root of M2 by M1 plus 1, that is equal to x. So null point position, if you want to calculate where is the null point, so the resultant force is 0, resultant electric field intensity is 0, that equation x is equal to R divided by under root of M2 by M1 plus 1. And one more, M2 is greater than M. Now we can discuss behavior of a body projected vertically up with a different velocities from the surface. Means if the, for example, one object is when an object is projected with a velocity v, if this velocity is less than the escape velocity, if the object is less than the escape velocity, what will be happen? That I want to calculate. Means velocity is less than the escape velocity. The projected object is with a velocity v. That velocity is less than the escape velocity. At that moment, it cannot be escaped from the gravitational force. It cannot be escaped from the gravitational force. So at that moment, for example, when object is on the surface, at that moment total energy on the surface of the earth is equal to, while it is going upward direction, it can reach at maximum height. It cannot be escaped from the gravitational field. So total energy at a height h. So total energy means potential energy plus kinetic energy at the surface is equal to potential energy plus kinetic energy on the height. It is at the height. Now total energy on the surface, total energy on the height. How I am writing means, see here, when object is on the surface, total energy is equal to, object is projected upward. So when it is attains maximum height h, that is total energy at the height. Potential energy on the surface, gravitational potential energy. What is the formula? Minus g m. Capital M is nothing but a mass of the earth. Small m is the mass of the object, and distance is nothing but a, when object is on the surface, what is the distance? It is r, that is r, plus kinetic energy of m v square. With what velocity the object is projected? With a velocity v. That is equal to potential energy when object is here, minus g mass of the earth, mass of the object, divided by, from here to here distance is, from here to here r, from here to here h. So total distance is r plus h. Kinetic energy of m 0 square. Why I am writing 0 velocity? When it is attains maximum velocity, maximum height, when object is reach maximum height, velocity will become 0. So velocity at the highest position is 0. From this one, see here, mass, if I take the common, get cancelled. What are the remaining cap? Here minus g capital M divided by r plus v square divided by 2 equal to minus g m divided by r plus h. Okay, this one I am taking right answer. V square divided by 2 is equal to minus gm divided by r plus h plus gm divided by r. This minus gm by r I am taking right answer. Again we can get here gm, I take the common. V square is equal to 2 gm. These two also I taken right answer. So first I am writing this is positive, this is negative. So positive one I am writing 1 by r minus 1 by r plus h. 1 by r minus 1 by r plus h. Now if we calculate this one, we can get it is nothing but a v square is equal to minus 2gh. V square is equal to 2gh divided by 1 plus h by r. 1 plus h by r. So we can get v square is equal to 2gh divided by 1 plus h by r. This is the equation. Otherwise you can write in terms of the root also this one. V is equal to under root of 2gh divided by 1 plus h by r. For example, if the velocity is v escape velocity by n, 1 by nth of escape velocity, v is equal to 1 by nth of escape velocity. At that moment, how we can write this one? Square only, if you keep this one, v square divided by n square is equal to v square divided by n square is equal to 2gh divided by 2gh divided by 1 plus h by r, 2gh by 1 plus r. Then if you calculate this one, h is equal to, if you calculate this one, h is equal to, we can calculate r divided by n square minus 1, r divided by n square minus 1. If you calculate this one, h is equal to r divided by n square 1. Okay, once again I want to explain this one, see properly. When applied velocity, projected velocity, when object is projected with a velocity v, that velocity is less than escape velocity. So maximum height is equal to how much means total energy on the surface is equal to total energy at the height. Total energy on the surface, potential energy plus kinetic energy on the surface, height, total energy means potential energy plus kinetic energy at the height. On the surface, potential energy, kinetic energy. Here velocity, on the surface velocity is v. When object is reached at certain height, maximum height h, potential energy minus Gmm by r plus h, because from here to here distance, from here to here up, from here to here h. So total distance is r plus h. Kinetic energy of m v square. At maximum height, velocity will become 0. At maximum height, velocity will become 0. So velocity is 0. Both side mass, if I take the common, get cancelled. This gm by r square I taken that side, and 2gm here 2 also taken. Gm take the common. V square I got it is nothing but a, if I calculate 2gh divided by 1 plus h by r. If 1 by applied velocity, the velocity of the object v is equal to 1 by nth of escape velocity. This equation if I substitute here, maximum height h is equal to r divided by n square minus 1. So in this situation, this is h is equal to r divided by n square. Now we completed when velocity is less than escape velocity, height is equal to r divided by n square minus 1. Now second case, if the velocity is equal to escape velocity, velocity is projected velocity, when an object is projected with a velocity v, that velocity is equal to escape velocity. At that moment, the object can escape from the gravitational field. The object can escape from the gravitational field, means at that moment small n is equal to, you can write as a 1. From this equation you can write n is equal to, when v is equal to ve means n is equal to 1. So h is equal to r divided by 1 minus 1, that is equal to infinity. When object is escaped from the gravitational field, so maximum height is nothing but a infinity. Maximum height is nothing but a infinity. Every time you have to remember, when object is out of the field, that is at infinity distance, we have to consider it is nothing but a infinity distance. That's why only we got it is answer also infinity distance. At that moment, when object is out of the field, total energy is equal to, total energy is nothing but a 0, potential energy plus kinetic energy, potential energy plus kinetic energy. What is the potential energy equation? Minus g m divided by infinity distance. R is equal to infinity distance plus half m v infinity whole square. See here, when object is at infinity distance means, otherwise when object is escape from the gravitational field, total energy is 0 and potential energy is equal to minus gmm by r is nothing but infinity distance. I given h is equal to infinity. Kinetic energy of m v infinity square means velocity at infinity, object velocity at infinity, means this part will becomes nothing but a 0. We can write as of m v infinity whole square is equal to total 0, v infinity is equal to 0. So velocity at infinity, velocity of the object at infinity is equal to 0. Velocity at infinity is equal to 0. Velocity at infinity is equal to 0. Once again, if object velocity is equal to escape velocity, at that moment n is equal to 1, you can write from here. Previous I derived this equation, n is equal to 1 I substituted. So maximum height reached by the object when it is velocity is equal to escape velocity, that is equal to infinitum. Object is cross the field, that is at infinitum distance. Total energy is equal to potential energy plus kinetic energy, potential energy, kinetic energy. Here V infinitum means velocity at infinitum, R is equal to infinite. Total energy becomes to 0 when object at infinitum distance, total energy is 0. So velocity at infinitum is equal to 0 in this case. Velocity at infinitum is equal to 0 in this case. Now first situation is velocity is less than escape velocity. Second case, velocity is equal to escape velocity. Now third one, if velocity is greater than escape velocity. If velocity is greater than escape velocity, in this situation also it can cross the gravitational field line. It can escape from the gravitational field line. At that moment, what is the velocity? What is the velocity? We have to calculate. Velocity at the infinitum position. In this previous, when velocity is equal to escape velocity, in that situation, velocity at infinitum is equal to 0, we got it. Now, if velocity is greater than escape velocity, velocity at infinitum is equal to how much? That we have to calculate. Now, to calculate that one, total energy on the surface is equal to total energy on the at infinitum position. Total energy at the infinitum position. So total energy on the surface means potential energy minus G m divided by R. Kinetic energy of mv square, and at infinitum means minus G potential energy minus G divided by small infinitum distance plus of kinetic energy is of m v infinitum square. Now in this one you have to observe this part will becomes to 0. Total energy on the surface means when object is here, at that moment potential energy this one. It is having kinetic energy, velocity is v, so kinetic energy is this one. When it is out of from the gravitational field, distance is nothing but a infinitum, velocity at infinitum, that we are calculating now. How we can calculate means, see here, this part is 0, both all sides small m get cancelled, minus G capital M divided by R plus 2 of V square of V infinitum square. Okay, we have to calculate this one only. So 2, if I take send this side, what will become here? Minus 2 G m by R minus this 2. Otherwise 2 I am taking this side 2 plus 2 by 2 V square is equal to V infinitum square. See here 2 get cancelled. We can write here from this equation minus 2G m by R plus V square is equal to V infinitum square. 2G m by R, it is nothing but a escape velocity equation. 2G m by R. So minus V square plus. Now this is escape velocity formula. So that's why I am writing it is minus V square plus V square, that is equal to V infinity whole square. So V infinity whole square is equal to V square minus V square. Finally I am writing it is V in velocity at infinitum, V square minus V square. It is important formula. See here, when velocity is greater than escape velocity, total energy at the surface is equal to total energy at infinitum. Total energy at surface, potential energy plus kinetic energy. So velocity at on the surface, so that is V I am taken. So potential energy at the infinitum, distance is infinitum. So velocity at the infinitum is nothing but a V infinitum. This part will becomes to 0. So here mass get cancelled, remaining terms I have written here. In this situation, this 2 I taken this side, 2 comes to a numerator, 2 get cancelled, and this 2gm by r, it is escape velocity formula. We already derived this equation. Then v infinitive is equal to v square minus ve square. V alpha is v infinitive is equal to under root of v square minus ve square. Now v equal to v and v is greater than v. Here energy is equal to negative and here energy is equal to 0. Here energy is equal to positive. In these three situations, if you observe, when velocity is less than escape velocity, energy is negative. When velocity is equal to escape velocity, energy is equal to 0. When velocity is greater than escape velocity, energy is positive. What is orbital speed means? Horizontal velocity required to the object to revolve around the planet is called orbital speed. Horizontal velocity required for an object to revolve around the planet in a circular orbit is called orbital velocity. Now this is Earth. Radius of the Earth, it is r. One satellite, it is revolving around the Earth. This dotted line is nothing but a circular orbit. Mass of the satellite is small m. Mass of the Earth, it is capital M. Mass of the satellite, it is capital M. Now we can observe the some gravitational attractional force between these two. Gravitational attractional force. Gravitational force Fg is equal to capital G, mass of the Earth, mass of the satellite divided by distance. Center of the Earth to satellite distance from here to here distance is h. So from here to here distance is r plus h. From here to here distance is r plus h whole square. It is equation number 1. So when it is revolving in a circular path means centripetal force is acting towards the center. The centripetal force is provided by the gravitational force. So centripetal force Fc is equal to m v naught square divided by r plus h. Here it is having the horizontal velocity is v naught. Satellite horizontal velocity is v naught. Centripetal force equation it is 2. So centripetal force is balanced by the gravitational force. At that moment you can write it is equation 1 is equal to equation 2. G m small m divided by r plus h whole square, that is equal to m v naught square divided by r plus h. Here r plus h get cancelled, mass get cancelled. The remaining terms are gm divided by r plus h, that is equal to v naught square. If condition I am using, if r is very greater than h, r is very greater than h, h can be neglected, h can be negligible. So gm divided by r is equal to v naught square. And one more equation, g is equal to gm by r square. Gravity on the surface of the earth. Gravity on the surface of the earth, we know this equation. So gm is equal to r square if you taken, that is gr square. G r square divided by r is equal to v naught square, get cancelled, under root gr. V naught is equal to under root gr. So escape velocity equations. This is in terms of height, this is without height. When you consider the height, we can use this equation. Without consider the height, we can use orbital velocity is v naught is equal to under root of gr. So orbital velocity, if you substitute g value 9.8 and r value 6400 kilometers, you can get 7.92 kilometer per second, isn't it? This is orbital velocity equation. Once again I am repeating. Satellite, it is moving in a circular path. Horizontal velocity is necessary to revolve in a particular orbit. So that velocity is how much? V naught. It is moving with a velocity is v naught, I am assuming. From satellite to radius of the earth, center of the earth distance is r plus h. So gravitational force acting between these two, earth and satellite, applied. Centripetal force is necessary, centripetal force is provided by the gravitational force. Now centripetal force is acting towards the center of earth. that is mv naught square by r. Equation 1 divided equal to equation 2. In this one, mass of the satellite get cancelled, this part get cancelled, remaining terms I have written. If r is very greater than h can be negligible. Gm by r is equal to v naught square. Here gravity on the surface of the earth, gm by r square. Gm is equal to gr square. R square r get cancelled, orbital velocity under root of g r.